Okay, so I'm going to start with this because I think if you're struggling with the code, you're probably struggling a little bit conceptually. So when you think of functions, think about Excel. There's all kinds of functions in Excel. Okay, so I'm just going to do a payment function. Oops. Okay. So the rate is that. Number is that. And the PV is that. Okay. So payment is the name of the function. This, inside the parentheses, is the data that will be sent to that function. So these three pieces of data, and Excel is nothing but a bunch of variables. So like every cell here is really a variable. You know, D1 is a variable, F4 is a variable. They're all variables. So we're sending some data. This one's got a little bit of math in it. Variable, variable. Let me just take this out just so you can see it. So, and it's returning a value and it's placing that value in this cell. It's assigning. So there's two types of variables. Or two types of functions. There's functions that return data and functions that don't return data. Functions that they all do something. They all do like a little specific task. Every function really is like a tiny little program that does one specific task. Sometimes they return a piece of data like this. This one also has data sent to it. So whatever data this is really like the input to the function is being sent here. So, you know, Excel's got a gazillion different functions in it. And they all kind of sit there in the background, you know. Let's see if I can find all. I always think this is amazing. How many functions are here? They'll sit there in the background. Okay. So somebody wrote them and they were stored. They're in the background. Nothing happens until you call it, until you type it in and say it has to happen. So there's three parts to a function. You have to write the function, create the function. So something's going on in this payment function. Okay, so somebody created this function. You have to declare the function. Okay, that's called the well, you're so ahead of me, I'm losing my terminology. You have to declare the function. I'll show you in a minute. And then you have to call the function. This is the call to the function here. And it's either going to assign something or it's not. So there are other functions in Excel that don't assign a value. So this truly, if I click on this comma style, there's a function behind that made that happen. It changed something. It changed formatting. The fill is there's a function back there also. So those are the void functions. The functions, that's actually the next chapter, chapter 10. What you're doing in this chapter are value returning functions. So your functions will all produce a value, just one value. Okay, so that's all they can do, one specific thing. So it's like a tiny little program with one piece of output. So you have used functions already. Okay. And you've used value returning functions and you've used void functions. So I know there's a point here somewhere. This is a point. ToLower is a function. This is one of the built-in functions into C++. It's in the background, okay? You send data to it, this YN thing, and it returns it and assigns it back to the same variable. You wouldn't have to return it, assign it to this variable. You could assign it to another. So this is the input to the function. This is a function itself. And when you call a value returning function, you need to assign that value somewhere else. So does that look something like this? If you read this, C4 equals the result of payments C2, C3, C1. Okay, so that's the call part of it. Where am I going here? You've also used one that's not value returning. That one? Okay. It does something, but it doesn't return a value. There is no assignment to it. But they have to be called regardless. A function has to be called regardless. So say I want a function that will return, I don't know, the square of something, not the square root, but the square of something. So first I have to give my function a name. And I'm going to declare my functions at the bottom. So it needs a name. It's called the function header. In front, I say what type of data it's going to produce. So it's going to produce a double. And then in here, I have to say what data is going to be sent to it. So this data is going to be sent to it from main. So right now what I'm doing is I'm declaring my function. And functions don't have to be large. So what this is going to do is it's going to take something from main. We're going to send it a variable, multiply it, and return it. So function header. It's got the name of the function, whatever you want to call it. It has the type of the data that will be returned. For these, it could be int, float, double, char, whatever. For the next chapter, it would be void. That's what we use when it's not returning anything. And then you declare whatever variables will be passed into it. This is considered a local variable. This is local to this function. It belongs to this function. Okay. And then after I declare my function, create my function, I have to declare it. I have to create a prototype, and it's really easy. You just take your function header, copy and paste it to the top, and put a semicolon at the end of it, and there you've got your prototype. Okay. So this is really declaring my function. So before you can use a variable, you have to declare the variable. Before you can use a function, you need to declare it. Another way to do it is to put all your functions at the top of your program, but that's a mess. Nobody likes to see that. So this is a better way to do it. And then here, let's see. I'm just going to I'll send you a link to this. This is just a tiny little program that you can play around with, try doing other things with it, modifying it to make it do different things, but you'll have like a basic format for a function here. So here's my function. I wrote my function. It's got a name. It has the data that will be passed into it. And it's got the type of data that it will produce or return. Right, that should be a double. Should also be a double. Okay. So then I take my header, copy and paste it to the top, put a semicolon at the end of it. That's my prototype or my declaration. Because the way the compiler works is it goes through line by line and translates it into machine language. If we don't have this, when I go to run my program, it's going to say this doesn't exist. It's this function is not declared. Square was not declared in the scope. It does not know that function exists because it's down here and it's compiling line by line. The prototype declares it just like you would declare a variable. So when you go to compile it, it knows that exists. Okay. So then when I call it, this information, the value of this, it's called passing by value, is assigned to this. This is actually a local variable that belongs to this function. It is created when the function is called. And it's assigned a value. So you know, like here we say, when we declare a variable, it's double number x equals 0, 0, or whatever. We've declared the variable, created it, and we assigned it a value. When we call the function here, okay, this variable is created and it's assigned this value. When the function is done, it produces or returns a value which is assigned to here. Okay. So hopefully this doesn't make it worse. But think about functions. Think about the functions you know. Think about functions in Excel. Okay. It's really the exact same thing. 3 parts to your function: coding the function, declaring the function, calling the function. Okay, so I'll include this link in the email, and I'll also send you a sheet that's got the logic for this particular program outlined. This is a program this is a concept that a lot of people hit the wall on, but it's one of those ones that makes sense. It's like, oh, that wasn't that bad really. But initially it's a little bit hard to get your head around. The whole idea is reusability, organization of your code. You can write your own functions and store them in header files that include them, just like they did there. So, but one step at a time.